So in the two marble examples, remember that when we drew with replacement, that the probabilities did not change in that problem. So let's scroll back up here. So when we drew with replacement here, probability of blue was 5/8 on the first draw, 5/8 on the second draw. Probability of yellow was 3/8 on the first draw. It was also 3/8 on the second draw. So whether you drew blue or yellow first had no effect on the probability of blue or yellow second. When that happens, we say the two events are independent of each other. However, in the second example, if you drew blue on the first, then probability of blue on the second was 4/7. If you drew yellow first, though, then the probability was 5/7. And same thing with yellow. It started out as 3/8. If you drew blue and then yellow, probability of yellow went to 3/7. If you drew a yellow first, then it went to 2/7. So that probability changed depending on what happened previously. When you have a probability change or a probability that depends on previous events, that's called a conditional probability. So conditional probability is when the probability of an event given that another event has occurred. So you're finding the probability of one event given that another event has occurred. And you write a conditional probability like this, E and then a vertical bar F. So what that means is probability of the event E, and the vertical bar means given that the event F here has occurred. So this is probability of E given the event F. And then the reason that we can multiply on the branches of the probability tree is because of what's called the product rule. So the product rule says that the probability of E and F, remember that your intersection there is and, is the probability of E given F, conditional probability, times the probability of F. So what we did up here in our marble problem is we drew blue on the first, and the probability of blue on the first was 5/8. That's this 5/8. So this was blue on the first. And then the 4/7, that was blue on the second, but that was given that you had blue on the first. Because if you didn't have blue, your probability of blue on the second was 5/7. So this is the event of blue on the second, given that you drew blue on the first. And then we multiplied those. And what do you get out of there? Well, this is our E, and that's our F, and then this is E given F. So that probability is going to be probability of E and F, so that's blue on the first and blue on the second. So these are really conditional probabilities in the second slot. They're conditioned on what you drew first, and the reason we multiply is because of the product rule. So just kind of keep that in the back of our mind for now, that the reason that you multiply on the branches of a probability tree is because of the product rule. Sometimes the probabilities change, sometimes they don't, but you still multiply on the branches. So let's look at another example with a probability tree. A basketball player attempts 2 free throws here. The player has made free throws 60% of the time in practice. But if the first shot is missed, then the probability of the player making that second shot falls to 40%. So they miss the first shot, they lose a little bit of confidence, so their percentage drops. What's the probability that she makes both free throws? So you can either make the shot or you can miss the shot. So let's let's label our event here. So we can either, let's label H for you hit or make the shot. You either hit or you miss. So H is that you make the shot. And then M is going to be that you miss. Okay, and then notice that that's the same as H complement. So if you don't hit it, you miss it. So on our first shot here, we can either hit it or we can miss it. And then if we hit the first shot, then on the second, we can either hit it or miss it. If we miss the first one, then the second one, we can either hit it or we can miss it. So now let's put some probabilities on these branches. So the players made free throws 60% of the time in practice. So that means the probability of hitting here is 60%. Well, then that means the probability of a miss is going to be 40%. And that's because these have to add up to 1 on the branches. So that 40% is really 1 minus 0.60. So now if they make that first shot, then the probability of making the second shot is still 60%. They've still got their confidence. And the probability of missing is still 40%. However, if they miss that first shot, so if the first shot is missed here, then the probability of making the second shot falls to 40%. So then probability of hitting that second shot is now 40%. And then the miss is going to be the 60%. So they switch. So here's our outcomes. We can either hit the first shot, hit the second. So you make both of them. Or you hit the first one, miss the second, hit and miss. Or you miss the first one, hit the second. Or you miss both of them. And then again, these probabilities in the second shot, this is first shot and second shot, those probabilities are conditional probabilities. This is the probability you hit the second shot given that you hit the first. This is the probability you hit the second shot given that you missed the first, because you're starting from a miss. So multiplying our branches like we did before, so 0.6 times 0.6 is 0.36. So we got decimal probabilities this time, that's fine. 0.6 times 0.4 for a hit and a miss, that is 0.24. Miss followed by hit, that is going to be 0.4 times 0.4, which is 0.16. And then two misses, 0.4 followed by 0.6. Multiply those and we get 0.24. And if you add these up to 60, these add up to 40, everything totals up to 1.00, which is 100%. And we want to know what's the probability that we make both. So that's 2 hits. So probability that you make both, hit the first and hit the second, product rule, is 0.36.